Hey everyone, and welcome to this new episode of Co-Creating with AI. I am Martin, and with me is my co-host Rasmus. How are you today, Rasmus?
Pretty good. I decided to switch up my recording location. Hopefully, trees and light won't disturb so much. How are you?
I'm awesome. I've been over the weekend. I was in Norway, and we were at the Geiranger Fjord in Norway, looking at the fantastic mountains and water and nature. That was incredible.
Yeah, it's funny,
And
like with Norway, like it's so close, like we're in Sweden, right? And I mean, I've been there, of course, but I haven't been there much. I went to Patagonia a bunch of years back,
yeah,
and then I just came across some, I think it was Swedish or at least Scandinavian um, travelers, and they were like, "Yeah, I mean, I've realized going here that Norway is just as good. It's just like 10x the price and
yeah,
10x the travel. So I
to
want to
go to
go
Patagonia.
for more.
No,
Yeah,
I can definitely recommend going to Norway. No matter where you are in the world, Norwegian fjords are worth a visit. Awesome. So, what are we going to talk about today?
I mean, I think it would be fun to dive a bit more deeper into the different ways you can like basically get an LLM to do a specific set of tasks for you. And
Yes.
I think a lot of people and myself included hear and maybe partially understand fine tuning, of course, training a model from scratch and just prompting a general model like GPT-4, which is probably what most people are most familiar with. But and I think you had something new you were passionate about that could illustrate it a bit. So let's maybe we should start there.
Yes. So, the three things you mentioned now are the basic ways you can adapt a model to perform a specific task. You can do prompt engineering, which is the most lightweight way, very accessible for anyone to just work with the prompt, develop it, and there, if you go into the OpenAI AI playground, if you're using the OpenAI models, you can work both with system prompts and user prompts, and so on, and develop patterns and workflows there to prompt AI to do a specific task better and better as you develop the prompt. And you can also ask the AI for hints and tips. The GPT-4 is not the best prompt engineer, but it's a good co-creator when
Mm.
writing prompts. And then there's fine tuning, which is less accessible. You need to know a bit about um, you like how you use the tools that go into um, training and of course fine tuning a model, and then creating a model from scratch is a whole different story because of the huge amounts of data you need and evals in order to get the model to work nicely. But of course, those are the three main venues, and different companies choose different ways and depths of adapting models to a specific task.
Right. So just like in terms of just before we dive into your example, just on the level of like data, right? Data and compute, I guess. First of all, training a model, a good model, is very like data intensive. You need a lot of data, right? And you need a lot of compute to train it because you need to run through this neural net like many times. And fine tune and then like prompting, you don't need any data. That's why they call it like a one shot or a few shot kind of results that you can get just with one good prompt. You can potentially get very valuable output, like or get it to do a specific task well. But when it comes to fine tuning, like when is that even? I know we're not going to focus there today, so
Mm.
just like when does it like make sense? Do you have any grasp of like the level of data you need? Is it like you know in comparison to training a model from scratch? Because I know it's much cheaper. You can fine tune via API. Via OpenAI, for example, you can fine tune their 3.5 model, I think.
Mm.
Do you have any sense of that or understanding?
Yes, so fine tuning is great for when you have a more complex task, where few shot prompting doesn't work. Few shot prompting means that you just give one or two or three examples of, this is how I would like you to answer this kind of question, or uh, if you're giving this text and the task of extracting all the city names, here's an example of a text, and here are the city names extracted from it. And then you can get it to conform very nicely to a specific output format, or a specific way of answering a question, or a tone of voice. If you want to, for example, um, um, you want the LLM to answer an email in the same tone of voice that you do, then just few shot prompting is enough. Give it one or two or three emails and say, copy my tone of voice and write an answer to this email,
Mm.
and it will do that nicely. However, if you want to capture perhaps your entire personality and breadth of working and thinking, then you can give it perhaps hundreds of emails and messages you've
Yeah.
collected from work, and you can fine tune a model on that, and then it will know how you react and respond to lots and lots of different situations, which can perhaps not be as well captured with few shot prompting.
I mean, that's great. That's like a great frame of reference for me, because then I sort of categorize it as whenever you want to have something like truly custom, like say a company having an internal kind of chatbot,
Mm,
that can actually represent the knowledge of the company knowledge in their systems. Or if you, as you say, basically want a digital copy of yourself. I remember like in an earlier episode, we took the example of like people at a Swedish tech company who had a boss who they loved who was leaving, and then they trained the model on him. Uh, and most likely what they did was like fine tune a model, right? If they took all his comments in all their internal tools and all his emails, etc., and then they had a little chatbot they could talk with. Would that be your guess as well? Because I don't actually remember like specifically how they achieved that. But would that be an example where you think fine tuning is what they like probably did?
definitely, I think so. But there is a nuance to be aware of, which is that if you want LLM to be able to um, copy different styles and formats and so on, and like ways of writing in a lot of different situations, then fine tuning is the best. But if you want it to know a lot of different kinds of knowledge, if you have a big database of facts that you want
Mm,
the model to learn, then fine tuning actually doesn't work as well. Then you
mm.
need to work with a semantic search, or different ways of putting the right data, the right knowledge and facts into the prompt. So, and you could also fine tune on the style, but uh, for knowledge and facts, fine tuning is actually not the right method to use.
Right, and I mean, and that's interesting as well because since LLMs are probabilistic, knowledge and facts are not like necessarily like even if you train. I mean, even if you train, and maybe we get in there, like in this example where they've trained in your example, but like even when you train a model on facts, you're not going to be completely sure that it's going to answer with facts if you're not sure that there are only facts in there, right?
Mm.
Because it learns probabilistically, right? Does that make sense?
Yeah, and it's also prone to hallucinations, of course.
Yeah,
If it doesn't have the facts, it will make up the facts, because what it
yeah,
has
exactly.
primarily learned is ways of reasoning and structuring text, and not the factual um, uh, contents. And also, if you listen to Sam Altman in some interviews, he says that he's actually thinking that their models, OpenAI models like GPT-4, are wasting a lot of um, precious data space on knowledge unnecessarily. The
Mm,
goal is not for GPT-4 to know a lot of things, but to be able to reason. And if they what he said was that if they could have had a method that only developed reasoning capabilities without storing facts and knowledge, and that's what he would have preferred. And just to allow the AI to be really really good at reasoning, and then you can give it the knowledge it should base its reasoning on, yeah,
Right,
afterwards.
right. Yeah, I mean that makes a lot of sense with like embeddings be like and the argument that the vector databases created by running embeddings on data can function as long-term memory. And you know the prompt or the history of like communicating with AI in this specific instance can be the short-term memory, right?
Mm,
Okay, I mean great. I mean I think like with the I don't know. Before I think we're going to have time for that. Before we dive into the examples of, I mean, contrasting training a model from scratch and
mm,
just prompting a general model, like just staying with fine tuning. We had a discussion, and this is probably going to be another episode, but just because I'm curious now, where we listened to a really good like A16C podcast episode, which I really recommend, about like AI as a second brain, right? So basically, hey, if I have a lot of knowledge I amass and have digitally that has been with me for a lot of years, you know, let's just for simplicity say it's my notes and my emails, right? Um, then fine tuning a model on that could, in theory, mean that I have no wait, because that is the knowledge question again. Okay,
mm,
so I back up. Yeah, no, I was gonna just to make that argument clear, uh, like what I may want to do and what is probably going to come is that I take all the digital knowledge that I have about me and then making it available to me when I need it. You
mm.
know, and that's the same for an individual as for a company. But then fine tuning wouldn't be the way because we're still missing in that aspect of like that's knowledge that I want to capture, right?
It can also be style. If you
Yeah.
want to, if you want the AI to copy your writing style with a really great level of precision in many situations, then fine tuning and using different ways of bringing data and facts into the context at inference time of inference, then that the combination of that could be extremely powerful.
Right. Okay, cool. Thanks. I just wanted to make that clear in my head. But let's
Mm,
let's jump into your example to like make this like sort of visualize this and just your own experience here, like with using
yes.
cursor.
Yes, so Cursor is an amazing fork of VS Code. There's um, it's readily available for free from cursor.so. There's a business model to it as well if you want to use GPT-4 and a fast version of GPT-4 that they have access to through an OpenAI partner program for startups. And then you can pay a monthly fee as well. But cursor.so is an amazing code editor, and it's VS Code straight up, but they've made a fork for future proofing their um, their editor as a platform. They could have built just a plugin as well, but like a plugin to VS Code, which is what most companies are doing, which is how GitHub Copilot worked and so on. But what they realized was that in order for GitHub Copilot to work as it should, um, GitHub and OpenAI actually got Microsoft to inject a new hook into VS Code as an editor, where they can
Hmm.
hook in their plugin. And Cursor realized we we might not be able to get Microsoft to do that for us if we need. So we need to have complete control of the editor code. So they forked VS Code completely, which is open source. And so Cursor might end up being the first really competitive fork of VS Code, that where it makes sense to use the fork instead of the original Microsoft main branch.
That's cool. I
And
mean, before we dive, just like why,
uh,
why do you think that? And like this ties back to like the concept of like AI native. And I haven't used this, right? But
mm,
but I'm just curious, like, because you and I've seen a lot of people get really excited about Cursor, right? So
yes.
like, if before we dive into like the this comparison we were talking about before, like, why are you excited and why do you think it's competitive? with VS Code?
Just because it brings the experience of co-writing code with GPT-4 into the editor instead of me working in Playground and copy pasting code back and forth, then copying
Mm,
um, the error messages that or compiler errors or runtime errors back into Playground in order for GPT-4 to take them into account when drafting the next version of next iteration of code. I can have GPT-4 live inside the editor in a great way and interact both on specific code blocks and on the file in general. And they
mm,
also have at um, when I'm chatting with GPT-4, I can do at and address a specific code file or even documentation of a code library. So I can say extract from at Node.js the specifics and tell me how to write this part of the code where I need to use Node.js documentation or we need to leverage Node.js documentation, and so it allows for the user to finally control what is in the context, and that is a huge nuisance with just using Playground or
yeah.
ChatGPT when you're coding.
And I think that's really interesting for me. And just like, how does that work then? Because is it that it actually then takes your whatever like namespace or lib you're mentioning, and it actually provides that in the prompt, similar to how I would in code interpreter like drop a CSV file. Is that actually how it works? That it just puts
Yes,
it in the prompt and
yeah, it
sends
puts
it
it.
now?
Yeah, it puts it in the prompt,
Okay.
and I can also nicely edit the system prompt. So I can put the general rules that I always want to apply, and so it's a really nice tool to manage both the system prompt and the user prompt or the context when prompting, and you can very easily continue the same thread of
Mm,
thought, or you can start a new thread from scratch. And by default, it always has the currently open file in context, and then you can at name other at reference other files to bring them into the context,
mm.
and they also have plans of automating and that so that the GPT-4 will automatically bring in the files it want to reference or need to reference when generating new code.
Also, it knows your library, like your general like what files are there, and it can say, hey, like it can actually pull those. It has
Yes,
access to
exactly.
pull those if it wants
Yeah.
to, as part of solving the task. Similar to like, I don't know if it was last episode or a couple episodes ago when we talked about the, I mean, it used to be called code interpreter, but the advanced data
Mm,
analysis that it can, use all these scientific, like all these libs, like all these, was it like PyTorch? You know what it was called? The different. I mean, for example, you took the example of image recognition, right?
mm.
Like that you could it had a lib for that, and it could use it. Is it similar here that it can like it basically you always like it automatic cursor always provides GPT-4 with, hey, these are the files available, so that it knows that it can pull them.
At
Is it
least
like,
that's in the tech plan, in the roadmap
okay,
that they have.
okay,
I'm not
okay,
sure that it currently does so, but that's in the roadmap.
yeah. And did you
And
ever
then
run into like context window there, like context window issues?
no, no, not so far. But and that's also because it's so easy to restart a thread over and construct the
Mm,
context that um, when I work in Playground with code, I've carefully worked a lot on setting up the right context, and I want to work
mm,
in that context for as long as possible. And then I run into going too far and extending the context window with so it doesn't fit anymore into what GPT-4 can handle with 8K tokens. And but since I don't have access to the 32K token version of GPT-4, and it's hugely expensive. It costs something
Yeah,
like almost $1 per call. Um, so that can easily amount to like
a lot of
$100
money.
or a couple
Yeah,
of $100 or just working one day, which can be worth it if like that's if you see it as a developer salary. It's a low salary, and like to pay a developer $100 per day instead of per hour. And but in any case, in Cursor, it's so easy to start over and reconstruct a new context that I can do it much more
mm.
often with uh, zero to low effort, and that means that I never run into issues with the context size.
That's amazing. I mean, that's like I think a real concrete example of like what I would call like an like I don't know like an AI native product, but like an AI first product, like that really thought like Cursor was made because it wants you to code with AI, right?
Yeah.
And then context construction, like taking whatever your like your files, having access to that, and then easily constructing context without it being an effort. That's I mean that really feels like a very general thing that the best like products, like AI first products, will do going
Mhm.
forward. Is like, okay, here's I have my relevant data in whatever the product is, and then how do I make that available in a good way, like when I need it to the AI to do something for me. Feels
Mm.
like a very very like concrete example for me.
Yes.
But yeah, going back to the start of where we started
Yeah.
this with like
So
the general prompting and the
so interestingly, since Cursor is a fork of VS Code, the Copilot, the GitHub Copilot plugin also works in Cursor, and not only in VS Code. So that and GitHub Copilot is it's a trained model, a model trained from scratch on GitHub open source code, and it means that when I work in Cursor, I get the benefit of both the proactive suggestions from GitHub Copilot, which is a model trained from scratch, and I also get the reactive input from GPT-4, which is a general model which I invoke in prompt and construct a prompt for. So it's two completely different methods of working. GitHub Copilot completely automatically constructs its context. I have no transparency in what's in the Copilot context. I have no control over it, but it still works beautifully because they worked a lot on getting that into a robust state. And and then with GPT-4, I manually construct the context and I manually invoke it. So so and then having both in the same editor is actually a really powerful package.
cool. I mean, that's really interesting to hear. So just like to see if I understand this correctly. I mean, when you train GPT-4 is basically trained on a lot of different types of data, but primarily in the form of text, right? That includes both code and blog posts, right? And Codex, which is behind then like the GitHub Copilot,
Mm,
it's trained on code, at least primarily, if not exclusively. And therefore, like if I understand this correctly, GPT-4, I mean, does next word prediction, right? Whatever
mm,
you put, like, or actually next token prediction, but what is the next token slash word going to be? And it's the same thing with Codex, right? But it's just like it's only trained, or at least mostly trained on code. So therefore, it's going to predict the next token, but in the context of hey coding. So
yes.
and really what it's doing is like providing that raw, prompting Codex is like, hey, this is my code here, please continue.
Mm,
That's literally what the model does in its base.
yes.
What comes next? And what they do is they can then provide that proactively because it doesn't need an instruction about what to do in the form of a prompt. It
Yeah.
literally is what it does, is predicting the next. And the only thing they limit, I guess, they instruct is that always instruct, it will always suggest, the next 100 tokens, or always
Mm,
suggest until the end of a, I don't know, what the relevant technical delimiter would be. But like, does that
Mm.
make sense? Is that like a
Yeah,
decent understanding? Yeah.
yeah, definitely. That's exactly how it works. And it's really like that's also a way that it differs. That Codex or Copilot is offering completions, while
Mm,
GPT-4 offers a chat completion where it's a back and forth sending messages between user and assistant.
mm. But could you theoretically, like with Codex, I don't know, this is maybe like a hard question to answer, but could you instruct it to write some specific kind of code? Like, could you say, hey, I want to build an app that does this? Do you know what I mean?
Yes, yes. So what you do is because it's a very common occurrence when you're coding, that you put a comment on top of each method explaining
Yeah,
what the method does. So if you write a comment saying, here's a method for sorting an array of strings.
yeah,
Then and then you enter new line. Then Codex will suggest the implementation of a method that sorts an array of strings.
yeah.
So it actually is also very possible to instruct it that way, like indirectly instruct it.
Right, because you just okay, right, because you just write the comment and then
Yeah,
it auto completes
yeah,
what is below the comment, which is code.
yes,
Yeah, okay.
exactly.
I
Yeah.
mean, that's really interesting.
And
Um,
you can
mm,
also do the opposite. If you write the method and then you go to the top and you say, like, you just start a comment, then it will suggest the comment for you, like interpreting what the method does into
mm,
text. So it can also produce text for you. Another example that a really, really good developer tool is find.com, Phind.com, which is a startup that produces a really good developer or programming um, chatbot, basically. And they have also leveraged this difference between fine tuning and using a general model. And also, it's a great example of context management, because what they have done is that they have indexed the documentation of probably hundreds of thousands of open source projects and libraries, and perhaps also commercial libraries. And so they have a semantic search, so they can pull into the context of their prompting any kind of documentation that the AI could need. And then you can prompt either a general LLM like GPT-4, which they call the smart model, and then you can prompt GPT 3.5, which they call the fast model. And then they actually have fine-tuned Meta's coding model, which is called Code Llama. So there's a model out called Find Code Llama. 32 billion parameters is in that model in the first version, and so they have done a fine tuning of the model that Meta has trained from scratch, and the fine tuning, they say, is actually performing better at human eval than GPT-4, like slightly better. And and so and then if you choose that model inside Find, they will say that you're now using the best model. So
yeah,
that's
of
that's
course.
their nomenclature. Yeah.
Best, smart, and fast.
Yes.
At least not slow, stupid, and slightly better.
Mm.
That's good marketing. But okay, cool. I mean, so but that's and right. So they took this. That's actually interesting. So like you could almost compare Code Llama to Codex, right? Like those would be like they've tried to do the same thing, train a base model on
Mm.
code. Yeah.
Yes.
And then what they decided to do here is fine tune that code model
Mm.
on a bunch of open source code,
Yes.
right? Or for
Yeah.
a specific, do you do it for a specific task, right? No, you just you do it on a specific data set, which implies the things like how you want it to think,
Mm.
right?
Yeah.
You basically run that data through the model again, and then it sort of the weights updates, like the neural net adapts. Like if I learn something, my brain will change a little bit.
Yeah,
if I
I'm
learn a
not
lot,
sure.
then
You
no.
can fine tune if you have a completion model like Codex. You can actually fine tune it to be a chat completion model.
Hmm.
So that might be also what Find have done with Code Llama to turn it into a chat model or a chat completion
Right.
model. I'm not sure,
Right.
but that's an example of fine tuning a model in order to make sure that it adheres to a structured output.
Right. 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 Yeah. Makes sense.
Mm.
I mean, we're running on into the half an hour now.
Yes.
But I mean, I think this was kind of a me asking question episode, but it leaves me more curious to understand even better, like, like what fine tuning is and how, like, in what different ways it can be applied. Because I feel like I have a decent understanding of, like, okay, we've trained a general model.
Mm.
It's next token prediction. It's trained on some data set. That means it's going to predict the next token based on that data set. And then prompting, which is just like based, like, instructing that model to do something,
Mm.
basically do next word prediction based on some kind of instruction that informs it, you know, which tokens to suggest or generate. But the fine tuning one, I'm still like, I still really want to dive deeper and understand. So maybe I'll try to do that, and we could have, like,
Mm.
find and find more examples. And I'm going to look into find as well. So thanks for
Yeah.
that suggestion.
Another small clue to understand the relationship between fine tuning and training is that fine tuning is basically just to train it a bit more. It's that you do the same, use the same mechanism to fine tune and train, but when you train a model, you start from scratch. It knows nothing, and when you
Yeah.
fine tune, you continue the training of a model that is already capable of something.
Yeah. Yeah, I'm just like curious how that feeds into, like, being able to control the output better to get it adhere to a certain output. But that's probably
Mm.
just me not understanding it well enough. But by
Yeah.
the way, before we forget, you had a show and tell today on the topic of
Yes.
co-creating
So
with AI.
I found this in Sweden. Coca-Cola has a bit of advertising, perhaps like, but they've um, released a series of 3,000 limited edition cans in Sweden of Coca-Cola Creations, which is a future-inspired flavor co-created with AI. And I just wanted to bring it to the show because and this podcast is, of course, co-creating with AI podcast, and Coca-Cola is now co-creating their flavors with AI. I think that's just an example, an amazing example of how both co-creation as a concept and AI as a concept is creeping into the mainstream.
Yeah. And does it taste good? Like, how is
Oh,
it?
yeah, it's really good. It's a
Good.
fresh flavor, fresh take on Coke Zero.
Cool. Good to hear. I mean, thanks a lot, Martin. It's been fun.
Thanks, Rasmus. Yes,
Yeah.
and thank you to the viewer as well for staying with us all the way to the end. And this has been an episode of Co-Creating with AI. As always, email us at Martin or Rasmus at multiply.co.
Have a good day.
Thanks.
Bye.